Did you know that we use a process called fractional distillation to separate hydrocarbons? This allows us to make many hydrocarbons from the same petroleum source. This lesson is on petroleum. So, petroleum is a liquid hydrocarbon formed over thousands of years from the remains of deep sea organisms or shallow sea organisms. And each component of hydrocarbon is called a fraction. And the process of separating and processing petroleum is called refining. So we want to separate the petroleum into different hydrocarbons. So the process that separates the different fractions is called fractional distillation. So we take our petroleum and vaporize it or turn it into a gas in a hot furnace. The petroleum vapors are then placed into a tall column, and as they rise in the column, they cool. Now, each fraction is going to condense at a different temperature to form a liquid. The fractions with the highest boiling points condense at the bottom of the column, and the fractions with the lowest boiling points condense at the top of the column. So before you can turn petroleum into usable products, you have to first separate it. And this is when refineries take advantage of the boiling points because the heavier or carbons that have the lowest boiling point will condense first, and this is like fuels for ships and factories. And the hydrocarbons that have the highest boiling point or lowest boiling point, like methane and propane, are fuels for refinery furnaces or camp stoves. So depending on the type of hydrocarbon, we use those as fuels for different vehicles. Smaller hydrocarbons are more useful than larger hydrocarbons because they more easily react. And when we need to break up larger hydrocarbons into smaller hydrocarbons, this process is called cracking. We're going to break it up into smaller components. So moving on to section 3.4. Hydrocarbon combustion is going to be the burning of hydrocarbons with water and oxygen to produce carbon dioxide and water and lots of energy. So when methane burns, it produces carbon dioxide, water, and energy. So the input energy breaks up the bonds in methane and oxygen, and then the atoms recombine to form carbon dioxide and water. Because longer hydrocarbons have more bonds than shorter hydrocarbons, they store a greater amount of energy, but they require more oxygen and produce more carbon dioxide, water, and energy. When we look at the formula for combustion, oxygen is always used up, and as a reactant, and carbon dioxide and water are produced as a product. We want to add coefficients to balance the carbon atoms, hydrogen atoms, and oxygen atoms. And remembering that the oxygen coefficient equals the total oxygen in the products. So this is in page 9 of your solution. So propane is on page 9 of your data booklet. So it says chemical involving propane. So we have CH3H8 plus oxygen gives us carbon dioxide and water. So we first want to balance our carbon atoms. So we had 3 carbons on our reactants, so we needed to make 3 carbons on our products. Now we want to add coefficients to balance our hydrogen. So we have 8 hydrogens in our reactants, so we need to add a coefficient of 4 to make 8 hydrogen atoms in our products. Now we have to balance the oxygen. So we take the oxygen from the carbon dioxide, which is 6, the oxygen from the water, which is 4, and we get a total of 10 oxygen atoms. So we need to add a coefficient of 5 to our oxygen molecule, which contains 2 oxygen atoms, to completely balance the equation. So typically when we're writing our chemical equation, we don't write coefficients of 1, so therefore our balanced chemical equation is CH3 plus 5 O2 gas produces 3 CO2 gas and 4 H2O gas. So the environmental impact of hydrocarbon combustion is that there's the production of a lot of carbon dioxide and water vapor. So both carbon dioxide and water vapor trap heat, which contributes to the greenhouse effect. Now, the greenhouse effect is important because it allows the temperature on Earth to remain warm enough and stable enough to contribute to producers and plants, creating oxygen and nutrients for life to be sustained on Earth. However, Too much carbon dioxide enhances the greenhouse effect, which causes the Earth to slowly warm up and change the climate. When we're looking at polymers made out of hydrocarbons, making polymers is the joining of many short unsaturated hydrocarbons. So we're talking about alkenes and alkynes, and we're joining them together. So the resulting hydrocarbon chain is called a polymer. So plastic is a polymer made by joining ethene molecules to make polyethylene. So we call this polyethylene. So polyethylene is created when we take the ethene molecule, which has a double bond. We're going to break that double bond open, and the carbon is now going to look to bond with something else. Now, if we have another broken ethene molecule, it will come and it will form a bond to this carbon. Now, many of these broken ethene molecules are going to join together to make a long chain called polyethylene. And this is a molecular compound where, again, N is going to represent the number of units in the polyethylene polymer chain. So we've broken apart those double bonds, and instead of bonding to more hydrogens, they've bonded to more broken hydrocarbons. Some other polymers include propylene, which is found in carpets and bottles, polyvinyl chloride, PVC, which is found in plastic wrap, synthetic leather and hoses, which is where we have a double bonded carbon with a chlorine molecule, and polytetrafluoroethylene or Teflon, which is found in frying pans, different cooking utensils, and electric insulation, which is made of many tetrafluorides. So there's carbons double bonded with 4 fluorides. The problem with polymers is that they take a long time to decompose or degrade, and sometimes these are called forever chemicals. And so now we're facing problems with the accumulation of discarded polymers, both physically in our environment as well as chemically in our environment. So some solutions that we can all contribute to are reducing our use and to resist buying products that have extra packaging. We want to reuse containers as storage and give toys to charity or secondhand stores so people can purchase secondhand and purchase secondhand yourself. We want to recycle plastic, glass, and metal whenever possible and rethink what you do and buy. So if we don't need to buy those plastic and polymer components, not as many will need to be made. Another sad side effect of polymers is when we have those plastic ring cans that hold pop or other liquid drink cans together. So it's important to cut each plastic ring collar before you discard it so that animals can't get trapped in those rings, because sometimes they'll get trapped, can't get out, and then they'll grow, and then that will end up cutting into their flesh and causing some distress or even death. We also wanted to encourage the use of biodegradable polyethylene, so that these rings don't linger in the environment. So if it's exposed to light, the chains break at each carboxyl group, and then they're more easily broken down by a natural process. The other option is to recycle the drink rings or collars wherever it's possible. I hope you enjoyed today's lesson on petroleums. I hope you enjoyed it. Bye.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.